small p, capital M, 0, capital E, small p, small p, additional small p. நான் உங்களுக்கு அனுப்பியிருந்தேன் உங்களுக்கு பார்த்து இல்லை அந்த பார்த்து போகணும் அவ்வளோதான். மற்றபடி கேபிட்டல் சி போடுறாங்க எல்லாமே ஸ்மால் சி தான். எம் பாஸ்வேர்டு கரெக்டா?
Hello.
Good morning. Good evening, sir. Morning, sir.
Yes, sir. I can hear you. Can you hear me, sir? Good evening.
Yes, sir. Yes, sir. Yes, sir.
Okay. என்னோட screen share பண்ண முடியல சார் இன்னும்.
வெப் அட்மின் கண்ட்ரோல் வச்சிருக்காரு.
Disabled participant screen sharing இங்க இருக்கு.
எஸ் எஸ் சார். ஹோஸ்டரா போடுங்க சொன்னாரு.
என்ன சார்?
co-host போடுங்க சொன்னாரு, பட் இன்னும் அவர் இது பண்ணல. எஸ் நீங்க ஷேர் பண்ணுங்க சார். இப்ப நீங்க you can share the slide, sir.
Okay, sir. Now. Screen
visible. Are you hearing me, sir?
Yeah, we can proceed, sir. Yeah, please. Already 10 minutes late. Yeah, I think more than that. Yeah, 10 minutes late.
Just you hide your slides, sir. Just hide your slides.
You want me to hide the slides, sir?
Yeah, you hide your slides. Yeah.
Minimize it, sir, or
minimize your slides.
Okay. Or you want me to stop sharing?
Yeah. So after introducing yourself and you share your slides, sir.
Okay. Can I keep open the cover slide or no need?
No, you just keep it as is.
Okay, now, fine, sir.
Yes.
Okay, fine, sir.
Shall we start, sir?
Yeah, please.
Yes, sir. HOD, sir. HOD is there. HOD, sir. Yeah. Anyway, we will start this second day section of the international webinar series. So, thing proceeded from the Lord. I am very happy to welcome you all to this second day session of a 4-day international webinar series on medicinal plants research and drug discovery. So, before we proceed this second day session of international webinar series, we seek God's blessing through the prayer. Lord, we are meeting today in the second day session of international webinar series. Guide our way and our minds in the right path. Fill us your grace and strength. We ask these things in your holy name. Amen. Thank you all. So let us welcome our resource person, Dr. Marimuthu. He is a professor of biotechnology. So I think many of the participants they may know today's resource person. Before we start this international webinar series, I would like to give some reminders. So, with your permission, I would like to give some reminders.
Yeah, please,
the organizers request all our participants please attend the entire session of the webinar. Kindly use the chat box for interactions and questions. Avoid unnecessary posts in the chat box. Attendance link will be posted by web admin at the end of each session. Please open the link in the web browser and post your attendance. Attendance is compulsory. Dear participants, e-certificates will be issued to the registered participants who attended the whole session, participated in online feedback as well as in attendance. So with this, we welcome all of you to this international webinar series. So first and foremost, I welcome our resource person, Dr. Marimuthu, Professor of Biotechnology, AMIST University, Malaysia. Professor Marimuthu, we are very honored to have you, sir, to this international webinar series. Welcome, sir. Next, I would like to welcome our vibrant head of the Department of Botany, Dr. S.R. Sendil Kumar. He is always supporting us by his encouraging words and his action. Welcome, sir. I also welcome Dr. David Raja and Dr. Jani Kumar Tagore. They are always supporting as a co-organizer in this international webinar series. Welcome, sirs. I am very happy to welcome all our participants to this second session of the international webinar series. So it is my bounden duty to welcome our resource person, so Dr. Marimuthu. So Dr. Marimuthu, he graduated UG and PG in zoology, Manomaniyam Sundaranar University, Tirunelveli. He did his doctoral degree in zoology from the same university. He started his research career as a junior research fellow in DST funded projects in 2000. He also did his postdoctoral fellowship in School of Biological Sciences, University of Sain, Malaysia. As a teaching staff, he started as a career as a lecturer in Department of Biotechnology, AIMST University, Malaysia in 2007. In 2003, he elevated as an associate professor in the biotechnology department of the same university. Now he is a professor of biotechnology of the same university. He has, in his research credit, he has successfully completed many research projects, and he has done various organizing programs. So his biodata is going like this. So with the lengthy biodata, so with the reducing the time of our session, so I'd like to stop here and welcome our resource person on my behalf, own behalf, and botany behalf, and the management behalf. Welcome you, sir. Over to resource person.
Yeah, thank you, Dr. Xavier, Francis Xavier. Thank you so much for a nice word and introducing me to the audience. Thank you for inviting me to be here and joining this international webinar on herbal-based research. Okay, so I have chosen this topic for the today presentation: role of herbal immunostimulants in aquaculture. Role of herbal immunostimulants in aquaculture. Where a variety of plants, variety of herbs have been used in aquaculture as a feed ingredients and also to stimulate the immune response. So before move on, I would like to show my university one slide, and this is the background. You see here is my university where I am working. Basically, we are a medical university, and we do offer medical MBBS, dentistry, pharmacy, physiotherapy, nursing, and engineering, business, and we have faculty of applied sciences whereby do offer BSc in biotechnology, MS in biotechnology, and PhD in biotechnology. And recently, we have introduced the BSc in bioinformatics, honors bioinformatics program. So the university campus is at 230 acres, 400 kilometers, which is away from Kuala Lumpur International Airport, and just 1 hour drive from Penang International Airport. Okay, so the center one actually is a library, and both sides is academic building, and this is actually is administrative wing, and this is the place where I'm staying, the staff quarters, and majority of the faculty members, I would say around 60 to 70% of the faculty members are from India. Okay, and these all student block. So regarding my presentation, these are the area I'm going to cover in my overview and my research area and global aquaculture and fish production. And some of the participants are botany based. So I would like to give you some scenario about aquaculture and fisheries, capture fisheries, and importance of fish and aquaculture system before we move on to the present day topic. And what are the challenges aquaculture industry is facing today, and the overview of fish immune system, why chemotherapy and vaccination is important in aquaculture, and then importance of immunostimulants, importance of immunomodulatants, and examples are some of the immunostimulant from herbal-based immunostimulant used in aquaculture, and what are the factors will affect the efficiency of immunostimulants when we apply in the field condition, and end with the characteristics of an ideal immunostimulants. Okay. And I have also included a couple of my own my publication also in the presentation. So my research area basically fish breeding, aquaculture specialized and fish nutrition, and especially naked fishes, freshwater fishes. And I have also done a little bit experiments and research on fish immunology and immunomodulators in aquaculture. And we have also got some funded project by Malaysian government, breeding and culture of aquatic leech. And we have done a couple of research on toxic effects of pollutants in fish model organism. And this slides you see here, this is actually breeding technology we have developed for breeding artificial way of breeding naked fishes. So this is my actually prime research area during my PhD, and a couple of my research paper on fish breeding related to that naked fishes. And in Malaysia, I have been working on this catfish. It's African catfish, exotic fish species, very commercially and widely available fish species in Malaysia. So we have also developed fish breeding technique for the fish species. Okay, so normally the catfishes we do induce by hormone, and this is the way normally we need to induce by hormone administration, and we need to allow for 12 hours, and after that, after 12 hours, we can collect the egg like this. So then we need to sacrifice the male fish. We have to remove the testis, and then we need to prepare a sperm suspension, and we mix sperm and egg, and we go for artificial fertilization. And this picture you see here, this is male and female fish. So this is a male fish, and this is the female fish. Based on the genital papilla, we can identify the male and the female fish. And when you look at the global aquaculture, and fisheries and aquaculture is an important source of food and nutrition livelihood for hundreds of millions of people around the world, and a lot of people depending on aquaculture as a job, as an economy, as well as day-to-day livelihood. And when you compare the world per capita fish supply available in 2016, it was 20.2 kg per individual overall, the global scenario. And then global population is expected to reach 9.7 billion by 2050, as per the FAO 2018 statistics. And hence, there is a great potential expected from the ocean and fishery inland water to contribute significantly to produce more fish for human food security and adequate nutrition for the projected this much 9.7 billion population. So this is actually the fish production from the capture fisheries and what you call inland fisheries. 171 million tons of fish we have harvested from capture fisheries and aquaculture in 2016. 171 million tons were available for human consumption. All right, of which 90.9 million tons we have got it from the capture fisheries. We need to say that river and sea capture, we don't manipulate anything, just we harvest. And in terms of 80 million tons of fish we have harvested from aquaculture, marine aquaculture and freshwater aquaculture. Before that, what do you mean by aquaculture? Culture of aquatic organism, including plants, aquatic plants, algae, and then molluscan, echinoderms, and then what you call prawns, crustaceans, and fishes, etc., including all aquatic animals. So aquaculture is the farming of aquatic animals, including fish, molluscan, crustacean, and aquatic plants, including algae and aquatic weeds, also important area of research in fisheries and aquaculture. So fish culture have been practiced in freshwater, saltwater, and brackish water, and globally intensive fish culture have been practiced in a closed spaces like ponds and cages and raceway, etc., whereby people they stock more number of fish inside the small area. So fish easily they tend to get diseases, right? And then importance, when you look at the importance of fish and aquaculture, is we all know that fish protein is a very vital protein for human consumption. And about 3.2 billion people worldwide, they rely fish as one of the major protein source. 3.2 billion people worldwide, they consume fish as per the FAO or the statistics. And fish contain 16 to 20 gram of protein. When you consume 100 gram of fish meal or fish edible tissue, it has got 16 to 20% protein, and also it has got essential minerals, vitamins, and also polyunsaturated fatty acids. It's very important for our human health and neural development for the children, etc. So compared to other meat products like chicken and goat, fish meat is easily digestible. Doctors normally, when you go to hospital, they don't advise you, don't eat the fish. They don't say like that. They don't recommend. So now, in fact, they will advise even children 1 year plus and elderly people also, they can consume fish. The reason, the fish meat is easily digestible. The protein somewhat easily digestible when compared to chicken meat and other animal meat products. Okay, and compared to other land animals, fish, they have a high multiplication capacity, meaning to say that 1 kg of fish can give 100,000 eggs. So each 100,000 eggs in 6 months time or 1 year time have the capacity to produce 1 kg, right? So that much capacity it is there in the fish for growing. And then low energy requirement for producing 1 gram of protein. For example, livestock, they require 22 to 400 kilojoules for producing 1 kg of 1 gram of protein, right? So, for example, in fish, they require very less requirements, 22 to 400 kilojoules for producing 1 gram of protein. Livestock, they require 500 to 3,400 kilojoules per gram protein production. So that much, so expensive, we need to provide them. And that's what economically the livestock animal is for meat production is not much economically viable when compared to the fish productions. And when compared to fish, they are very easily convert the feed into flesh. For example, if you give 1.5 kg of feed, you can expect 1 kg of flesh. Highly efficient than the poultry and other animal products, animal culture. So if you give 1.5 kg of feed, you can get 1 kg of flesh. So that much easily they can convert, the feed will be efficiently converted into flesh. And the fish has got a streamlined body, has got variety of essential vitamins and essential minerals, and very well is needed for the health, human health. Phosphorus, magnesium, manganese, fluorine, and also vitamin E and essential fatty acids and vitamin D and vitamin B12, zinc, etc., iron, etc. So generally we used to call seafood. Seafood means it comes under fish, molluscan, and then crustaceans, even aquatic algae, marine algae, all comes under that seafood. Normally, generally we used to call. So fish has been cultured in a variety of ways. Earthen pond, we also culture in circular ponds, raceway, floating cages, strings, race, monoculture and polyculture. And then we also do integrated fish farming, culture of fish and plants together, right? Culture of paddy and fish together, integrated farming, culture of poultry and fish together, right? So now the aquaponics is very gaining prominence globally, culture of vegetables and plants, soilless agriculture. Without soil, we can cultivate plants along with the fish. So meaning to say that the fish waste, the aquaculture used water can be used for culture of plants cultivation, whereby water is purified and water also usage also can be minimized. And this is very popular in countries like desert countries like Israel and Gulf countries. Aquaponics gaining much prominence. So aquaponics require very less water compared to other culture systems like earthen ponds and other things. Okay, I will show you later the pictures of aquaponics, how the system it looks like, and the principle of aquaponics. So this is actually a very common culture system globally, earthen ponds, very simple. Anyone easily can pick up and practice and start having the aquaculture. Earthen ponds. And this is actually, see here, extensive earthen ponds. Globally, this is a very predominant culture method, earthen ponds. Very, very simple to construct and operate. And this is in Indonesia. And this is actually a cage culture. Cage culture means a kind of net enclosure. We install the system into the open water, meaning to say that sea and lakes. And no need to worry about the water quality parameters, no need to worry about the feed. And sometimes if people, they go for intensive aquaculture in this kind of cages, they stock more number of fish inside, and then we need to give them feed as well, commercial feed. So this is actually a kind of a system, aquaculture system, canvas tank system. And this is some kind of portable. If a farmer has got a small land area, a backyard, those kind of people, they can go for it. And very simple. Actually, this is a polyethylene material, right? And all the four corner has got the iron rod, and we can hang this, what you call the bag-like structure. We can hang it, and somewhat very easy. We can also set the water flow. We can monitor the fish growth very well, and we can monitor the fish feeding as well. And especially the carnivorous fishes, shallow water fishes can be used for this kind of culture system. And this is another one is called tank, cement tanks. And this is also very common in aquaculture system. So fish species like tilapia and catfishes can be cultured using this kind of system very well. And this is a duckweed culture. It's duckweed is used for as a feed material for fish, poultry, and cattle. Duckweed. And this is what I have mentioned, aquaponics. So this is a fish culture system, and this is a plant cultivation system. Plant cultivation system, we use this kind of pipes, or we go for a kind of substrate like gravels and pebbles, right? But we don't use any kind of sand and clay. And without soil, we are going to cultivate the fish. And here we culture the fish, and the fish culture water can be channelized into this media, plant cultivation media, substrate. So water is purified, and the microbes will be present in the gravels. Plant absorb the nutrients, microbes convert the ammonia into edible nitrate. So plant can utilize the nitrates, whereby the water is purified and the water comes to again to the fish culture system. Okay, so whereby no need to release the water. We are not wasting any kind of water. And this is what? This is an indoor system, aquaponic system. This is the fish culture tank. And here we can cultivate this kind of, we prepare media like this, gravel, a hytatone, or stone, gravels, etc. And we can culture pudina, mint, and any kind of leafy vegetables, right? So this culture water, continuously we have to pump and place it this kind of tanks. So water will percolate through this media, and whereby the bacteria will be present in this media, the gravels and pebbles. Plant utilize the nutrients, whereby the water is purified. So the purified water again channelized to the fish culture tank. It's a kind of flow-through system, running flow-through system. So water is moving from fish culture tank to the plant cultivation system, and again water comes back to the fish culture, the system, whereby the water is purified, and we are not wasting much water, and simultaneously we are getting a dual crops. One is a vegetable, another one is a fish. Okay. And this is also a very common system in India as well as Sri Lanka, Bangladesh, and China. Paddy cum fish culture system, integrated farming. So one portion we cultivate the paddy, and like these patches of land, we leave it for fish culture. Okay. So air-breathing fishes like Chana striatus and the tilapia and catfishes can be cultured in paddy field, right? So this is called paddy cum fish culture. And yeah, this is the way people they do harvest. And this is another interesting culture system is integrated farming, poultry cum fish farming, poultry cum fish farming. So we need to say that fertilizing the water, normally we add inorganic and organic fertilizer to make the algal growth, algal bloom. So to avoid that, we also can construct this kind of poultry shed on the what you call the surface of the fish pond. The poultry droppings directly delivered into the aqua system, pond system. So the poultry droppings can fertilize the water, right? So this way we can minimize the fertilizer needed for aquaculture, and also we have a dual crops, chicken protein as well as a fish protein for human consumption. So this is something economically viable for small scale fish farmer. So then aquaculture industry facing a lot of challenges, and number of diseases, number of parasitic infection, and a lot of antibiotic have been used, right? And pesticides have been used for controlling pests and other animals in the what you call pesticides means, for example, you set up any kind of aquaculture system nearby the paddy field. When pesticide runoff we cannot avoid, and then biofouling of structures, especially in the marine aquaculture, right? Biofouling means snails and other things, they will damage the aquaculture system and cages. And then toxins from the algae. Algae also, if any unfavorable condition, algae releases some toxins that will affect the fishes and physiology. And then climate change, So these all will limit the aquaculture productions. So these are the factors will hinder the aquaculture fish production worldwide. So globally, an intensive fish culture have been practiced to increase the fish productions. Fish culture practiced in salt water, brackish water, and fresh water. And when you go for intensive fish culture, meaning to say that in a small area, we stock more number of fish. So these practices will suppress the immune system of the fish. And this kind of stressful environment will create the fish will be in a kind of suppressed immune system. And also the fish will easily get the diseases, especially the shellfishes and to the infectious diseases. And aquatic animals controlling of diseases is very, very tedious and cumbersome. So similar to vertebrate animal, fish has got two type of immune system, innate immune system and acquired immunity. And the main primary lymphoid organs are thymus, anterior kidney, and the spleen. Okay, so fish has got both non-specific and acquired immunity like other vertebrate animals. So when you look at the non-specific, the primary defense mechanism actually is a physical barrier like skin, scales, and mucus. Fish has got variety of scales and thickness, the skin thickness, and also has got a lot of mucus on the body. It has been proven that the fish mucus has got number of antimicrobial proteins, can eliminate the majority of the microbes. If the mucus doesn't work, the pathogen can penetrate the fish and damage and create the disease and kill the fish. And also number of chemical mechanism also present. Chemical enzymes are present in the mucus. Enzymes like lysozyme and also immunoglobulins are present in the fish mucus. This will eradicate or control or prevent the microbial infestation in aquatic animals. So we have characterized mucus from fishes, and we collected the mucus from one common fish in Tamil we used to call viral mean, and we have done a variety of extraction, crude extract, aqueous extract, and acidic extract. And the mucus extract were tested with a number of human pathogens, and the acidic extract was found to be antimicrobial inhibition, especially it controlling Bacillus klebsiella and also Pseudomonas aeruginosa. And we have also calculated the minimum inhibitory concentration for the acidic extract of the fish mucus, especially 3% acetic acid extract. And fish has got specific immune system, humoral and cell mediated, and humoral immunity consists of lysozyme, hemolysin, immunoglobulins, and cytokinins, whereas cell mediated, it includes phagocytes, neutrophils, and natural killer cells and lymphocytes. So when you look at the immune system of fish and vertebrate animals and humans, more or less similar, all the system, how the mechanism, how does it work. And when you look at the fish diseases, there are two types of fish diseases. One is infectious diseases, another one is a non-infectious diseases. Infectious actually is a disease caused by organisms like bacteria, fungi, virus, and parasites. Non-infectious, it is due to nutritional disease, environmental disease, chemical disease, and physiological disease. Nutritional means any kind of lack of nutrients. The fish will get disease. Environmental means environmental pollutants, pesticides, right? Chemical diseases and physiological diseases due to excessive accumulation of pesticides. These are all non-infectious. They cannot, infectious and non-infectious diseases. These are all based due to environmental changes. So non-infectious nutritional diseases, it is due to the deficiency of nutrients, hypovitaminosis or malnutrition or excess of nutrient. And also the toxic compounds present in the feed ingredients. For example, when you use spoiled feed ingredients for the feed formulation, will have some kind of fungal toxins that will create a toxicity for the fish, and fish will get disease. Okay, and too much of food also can cause a problem. Too much of fish also can pollute the water, and polluted water will create unfit. The water is unfit for healthy living of fishes. Environmental diseases, it is due to the changes in the water quality parameters like too much of ammonia and too little of oxygen, and any kind of heavy metals and pollutants, pesticides This all comes under environmental and chemical diseases. Physiological diseases actually is like a human and other vertebrate animal, abnormal development of the internal organs, like a swim bladder, and abnormal body structure, abnormal vertebrae, right? So these all will create it's a kind of abnormality in fishes also, vertebral abnormality, right? Scoliosis, this is all very common. So these are disease-causing organisms, virus, bacteria, fungi, protozoan, and crustacean parasites in aquaculture. And controlling them is very tedious process. And the control, suppose if you culturing aquaculture, fish, and if you don't get any kind of diseases, you are lucky. And if you get disease, and controlling diseases in aquaculture is very, very difficult and very tedious. Hence, immunostimulant and probiotics are gaining much prominence in aquaculture industry. So these are some of the bacterial disease in fishes, names of bacterial diseases: flavobacterial, bacterial disease, columnaris. I think majority of the participants, I hope, botany based, and these names may be for you kind of funny. It's okay. Fearenclosis, enteric red mouth disease, enteric septicemia of catfish, and vibriosis, bacterial kidney disease. I'm not going to go for much detail on the symptoms and diagnosis for this disease. Just I am going to give you some names of bacterial diseases, etc. And parasites also very, very common. Can you see here? This is one kind of parasites, Argules. And this is also one kind of parasites, Lernia. Very common infestation. Even aquatic leech can damage the fish and also create injury, whereby the primary injury and followed by the secondary infection by bacteria, right? And has got endo and ectoparasites. Can you see here? This is a predominant fungal infection in ornamental fishes and also especially in the hatchery. And this is actually a fungal growth, Saprolegionella, Aphanomyces, and Brachomyces, very common in aquaculture hatchery as well as ornamental fish. And can you see this is a whitish growth? This is due to the excessive fungal growth, right? So we can use antifungal to eradicate. But having this kind of disease is this kind of growth, fungal growth, is very, very difficult by applying any kind of antifungal to cure the disease. And this is also one common disease, Aphanomyces invadens, and very common in India as well, this disease, epicyclic ulcerative syndrome. You will see this kind of injured portion throughout the body, this kind of reddish swelling and a kind of bus also. You will see this kind of ulcer kind, right? So this is due to the Aphanomyces invadens. The disease is called epicyclic ulcerative syndrome. So hence, a variety of chemotherapy have been used, antibiotics and antimicrobial agents have been used for controlling parasite, bacteria, fungal diseases, etc. So antibiotics like amoxicillin and erythromycin, oxytetracycline, enrofloxacin have been used, but excessive use of this antibiotic has got a lot of problems, right? Even customer also, they do resist. If the fish are fed with antibiotic, and accumulation of antibiotic in the body will suppress the growth as well as will give now some negative impression among the customer, right? So antibiotic accumulation in fish tissue also will affect the human, okay, and reduce the consumer preference for food fish treated with any kind of antibiotics. They will resist to buy your fish if your fish fed with antibiotics. So then another approach for controlling disease is a vaccination. Vaccination also is the most promising and effective prophylactic measure of controlling fish and shellfish diseases in aquaculture. However, they are relatively very, very expensive, and vaccination is very, very pathogen specific. That is what globally for vaccine for COVID-19, challenging, people are exploring. But vaccine, remember, is a species specific. If there is any kind of virulence, any kind of mutant form, then the particular vaccine doesn't work. It won't work. So we have to look for additional species specific or strain specific vaccine. Okay. So a couple of vaccines are available for controlling fish diseases in aquaculture. But remember, vaccination is a specific for a particular disease. So there is no but one vaccine is available for controlling number of diseases. So vaccine is effective for selected the pathogens, bacterial and viral diseases. So hence, immunostimulants is a major role. Hence, immunostimulant is a major role. We can kind of prevention of disease is a very, very important. Prevention is better than cure. Okay, so immunostimulants comprise a group of biological synthetic compounds enhance the innate or non-specific immune response of the animals, like ginger, garlic. Normally we use, right, traditional food we consume, so that will boost our immune system, right, so that our body will be strong enough and fight to the foreign pathogens, so foreign bodies. Okay, so immunostimulant collectively or interchangeably called as immunomodulators, adjuvants, biological response modifiers. Immunostimulants can be grouped under chemical agents, bacterial preparations, polysaccharides, animal and plant extracts, herbal extracts, and nutritional factors, cytokines, antibacterial peptides, and products of microorganisms have been tested, validated in aquaculture. So these all can enhance the primary defense mechanism of the innate immunity of the fishes. Widely used for impaired immune function, immunostimulants are of great interest in aquaculture and have become one of the most active area of applied research in aquaculture and fisheries sector. Actually, this is one area of research in fisheries, fish immunology and immunomodulation and probiotics. And these are some of the examples of immunostimulants, immunomodulants have been used in aquaculture industry. Lipopolysaccharide from the bacterial cell wall, and glucans, synthetic polysaccharides, and vitamins. Variety of vitamins have been tested in aquaculture as a immunostimulant, immunomodulatory activity. And animal and plant extract, azatrican and piperine, curcumin, osmium sanctum, aloe vera extracts have been explored. Ginger, garlic, all are tested in the fish model organism to study about the immunomodulatory activity. And then a couple of antibacterial peptides have been tested in fish model, in finfish and shellfish species. So herbal immunostimulants, herbs are currently used in commercial aquaculture as a growth promoting substances, antimicrobial agents, and also as a nutrients. Herbal drugs are known to possess immunomodulatory properties and generally act as by stimulating both specific and non-specific immunity or immune response variables, parameters in fishes. Examples: leaf extract of osmium sanctum. It stimulated both antibody response and neutrophil activity. And dietary intake also enhances antibody response and disease resistance, especially Aeromonas hydrophila. So this is one of the predominant bacterial species. Okay. And other plant species like Nelumbo nucifera lotus, Solanum trilobatum, I do not know the exact Tamil name, recently I have done this, and Pilanthes implica, Azatrica indica neem, aloe vera, curcuma langa, and Piper vetilli, and Muria collingi, and Mentha pipetta, and Astragalus membranus, garlic, and a number of Chinese herbs like Polygonum and Clizeria glabra. So this kind of plants, herbal plants, medicinal plants have been tested in aquaculture as a immunomodulatory immunostimulants. I will cover a couple of slides about the different plant species and what dose and what extract, what solvent they have used it, and what fish species and what dose and what pathogen the particular immunomodulatory activity of the plant were tested. Okay, so these are the plant species. These are the plant species. I think this slide is somewhat very not clear. I don't think so. Whether is it clear? Okay. So different parts, leaf and stem and root, aerial parts have been tested, right? And these are the solvents have been used. Maybe later I will share the slides to Dr. Francis Xavier, and he will forward to you all if you are much interested to know about what are the plant species and what are the concentration and what administration, what mode of administration, through the oral administration or through injection or by bathing. So different methods, normally we use it for administering the immunostimulants in fish. For example, in human, antibiotics, how do we take? We go for injection, and also we take orally by not taking through the mouth, right? Oral intake of antibiotic. Similarly, fish also. To orally means we have to incorporate the antibiotic, incorporate the herbal immunostimulants along with the feed. Okay, so that the fish can consume. So the what you call the stimulants can elevate or elicit the immune response parameters. And these are other plants. And a couple of research have been carried out. A combination of plants, combination of 2-3 plants, herbal plants, been tested. Okay. So herbal plants stimulate both humoral and cell-mediated immunity, while others activate only the cellular components of the immune system, especially phagocytic function. Stimulate the phagocytic cells. The phagocytic cells can inhale the foreign body. So some plants are rich sources of compounds like volatile acids, oils, saponins, phenolics, tannins, alkaloids, polysaccharides, and polypeptides. These may promote the immune response of the fishes. So these natural plant products have various activities like anti-stress, appetizer, antimicrobial, as well as immunostimulant activity in fish model organisms. Number of numerous research have been carried out in fish model using herbal immunostimulants. And we have done, this is one of my undergraduate student project. And mangosteen is a queen of fruit, and it's a very highly edible fish, edible fruit, right? It is commonly available in Malaysia. Very common, mangostan fruit. In Tamil, we used to call mangostan. In English, we used to call mangosteen, right? So normally we consume the edible portion. But the rind has got a variety of thick layer, the rind, pericarp. So we use that rind and a variety of other products from the what you call mangosteen. We tested in fish model. We use this Clarius caripinus fish model. Okay, and this is a pericarp we tested, pericarp, and also along with a leaf, right, and also shoot. We have incorporated 5% of the leaf, shoot, and rind extract along with the feed, right, and the fish were fed with 5 weeks. The what you call the plant extract incorporated feed for 5 weeks. So we have measured the growth parameters, and also we measured the food conversion efficiency, right? So we found that shoot extract elevated the immune response parameters very well, like boosted the RBC, boosted the WBC, and also increased the level of hemoglobin recorded in leaf and what you call rind extract incorporated protein. I think people also, they have suggested that mangosteen juice also available from the rind. Mangosteen has got a lot of xanthones it seems. Okay. And another study also we have done, and this is my student now. He is doing postdoc in Australia, and this is his undergraduate project. And we have also published this in long back, I think 10 years old. This study, right? So normally we consume only the garlic, right? The white one normally we don't consume. The white, the outer, the waste normally throw away. So what we did, we collected the white, the outer the layer, the peel, right? So we have prepared the different concentration of peel, 0% and 5.5, 1% and 1.5%. We have incorporated the peel into the fish feed, and the fish were fed with the 5 weeks, right? And this is the one we have used it. This normally we use it for cooking purpose. This one normally we throw away. But we tested whether it has got any property or not. So we found that the survival has been increased in the higher concentration. 1 gram and 1.5% of incorporation of the garlic peel. And also we found that positive growth and positive weight gain and specific growth rate elevated in the 1% and 1.5% incorporated the garlic peel. And elevated protein, elevated albumin, elevated globulin, RBC, WBC in garlic peel fed fishes than the control fish, whereby the fish were not fed with any garlic incorporation. And there are two main procedures have been used for evaluating the efficiency of herbal immunostimulants in aquaculture. One method is in vivo, another one is in vitro. In vivo means we challenge the fish with the pathogen. Normally, we administer the immunostimulants and give them for 5 weeks. The fish will consume, and after the feeding trial, we challenge with the pathogen. We look at how resistant the fish against the pathogen, right? And also we monitor the growth when compared to the control. And then we also look at the synthesis of antimicrobial substances from the serum. This is in vivo effects. Whereas in the in vitro effects, we look at this kind of assay. Phagocytosis, radical productions, enzyme activity, migration activity, and production of cytokines, nitrous oxide production, bacterial killing, antibody productions, and cytotoxicity, cell division. These all been done. Okay, so no need to look for all activities, at least one or two can be used for elucidating the immunostimulatory activity of a particular herbal products or any animal product having any immunomodulatory activity. So list of pathogens have been successfully controlled by immunostimulants in aquaculture. A number of bacterial species have been controlled, number of viral been controlled with immunostimulants, and one parasite, Ichthyopteris multifilus, been controlled with immunostimulants. And then mode of factors will affect the efficiency of the immunostimulants. What are the factors will affect the efficiency of the immunostimulants? So there are variety of route of administration, and mode of administration is very, very important. Whether you are administering through the injection or administering through the oral or administering through the bath. Bath means we prepare the extract in the water whereby we release the fish. So each method has got advantages, each method has got disadvantages. So another factor is how much dosage is important. How much dosage of plant extract active principles need to be incorporated into the feed to have the immunomodulatory activity dosage. Okay, so mode of administration, injection, bathing, oral, and intraperitoneal has been proven successful by Arizona et al. And incorporation into the diet is most promising. So we have done in my laboratory, incorporation of diet is something promising, somewhat very easy, conducting the study in the laboratory condition instead of going for intraperitoneal injection. So intraperitoneal injection means each and every individual fish we need to administer the hormone into the peritoneal cavity. Sometimes if a particular candidate doesn't have much hands-on skill, can damage the internal organs. The fish are so delicate, handling them also very, very sensitive. So what are the ideal characteristics of an ideal immunostimulants when you look for it? I think I have come to the end of the slide, I think. Yeah. So characteristics of an ideal stimulants, whatever the plant species herbal plants you choose for immunostimulants in aquaculture feed formulation, it should not be toxic, and also it should not be non-carcinogenic, and it should not have any long-term side effects. At therapeutic level, it should have short withdrawal period, meaning to say that when you incorporate the plant or herbal drugs into the fish feed, should not be there in the body tissue. Okay, and it should stimulate a wide range of non-specific immune responses against bacteria, fungi, virus, protozoa, and nematodes or platyhelminthes. And then breakdown products of compound concern should be either inactive or readily biodegradable in the environment. You should be having a defined chemical composition and biological activity, and active principles need to be elucidated. And it should be active by oral route and should be stable both in its native form as well as in the incorporation. Meaning to say that in the laboratory condition, it may show the efficacy, whereas when you test the same thing in the field condition, they may not show the efficacy, right? So it should be compatible with a wide range of other chemotherapy like antibiotics and antihelminthics, and it should be very inexpensive. Okay, so herbal immunostimulants, they have a great potential as an immunostimulant in aquaculture because they can be easily prepared or inexpensive and act against a broad spectrum of pathogens and parasites. And most of the herbs and herbal extracts can be given orally, which is the most convenient method of immunostimulation in aquaculture. And in conclusion, I think I have rushed through. I think I have taken 40 minutes time. I have taken 40 minutes of time. And the use of immunostimulant is very promising in aquaculture. And this is one area of research. And there is one journal called Fish and Shellfish Immunology, right? So especially in every issue, every month, I think we have one volume, right? Every issue, there will be one or two immunomodulatory related research, probiotic related research will be published in a particular journal, has got 3.7 or around 4 impact factor. So although vaccination is the most reliable method of controlling fish diseases, as yet no effective action against a bacterial kidney disease or most viral infection in prawns and fishes. So immunostimulants are safer than other chemotherapy and their range of efficacy is wider than vaccination. So therefore, immunostimulants may be a powerful tool for controlling infectious diseases in aquaculture, and more research is needed for exploring the bioactive principle of a couple of herbal plant species used in aquaculture industry as a immunostimulatory activity. Okay, so with that, I have come to the end of the session. And if you have any couple of questions, I'll be very happy to answer those questions. Okay, so thank you so much, Dr. Francis Xavier, for giving this great opportunity and having this online session. It's a kind of boring session, right? It's a boring, and without seeing the participants, we have to monotonous, we have to talk. Okay, but no other way, this particular scenario, particular situation, so we have to move along with the prevailing conditions of COVID-19. Okay, and I would say a lot of happenings, a lot of events happening during this what you call COVID-19. Globally, a lot of webinars and increasing our knowledge. A lot of every day there are a couple of activities going on globally, right? Yeah. So a lot of positive and a lot of negative. Okay, so let us keep it as a positive mode and keep moving. Yeah. Thank you. Any questions?
Thank you, sir. Thank you for your excellent presentation on the topic given. Sir, though you visited many countries like China, Taiwan, Malaysia, Indonesia, Sri Lanka, and Thailand.
Oh, yes, sir.
I hope you are very happy to present your research expertise with our Indian participants. With your research expertise, they may get much knowledge in the field of medicinal plants related to the immunomodulatory things. Thank you, sir.
Yeah, thank you so much, sir.
Thank you. So we have a lot of questions received in the chat box.
Yes, sir.
So we have selected some questions
Yeah, please, sir.
based on the merit, of course. We are going to ask some questions on behalf of participants.
Yeah, please, sir. We are most welcome.
Yeah.
Please carry on.
This is a question from Purnima Paul. Purnima Paul. So that question is, can poultry farming and aquaponics be combined? Can we combine farming, poultry farming and aquaponics?
So you have to explore, so there is a different principle. Poultry farming and aquaponics, so there is a different principle, but you have to explore. You are incorporating one more animal protein inside in the system. I don't think so. Any kind of poultry with aquaponics, I don't think so. But you can still explore possibilities there. Okay, and too much of nutrient also sometimes will pollute the system. Reason aquaponics we go for a small area. The purpose is small area and utilize the water effectively, and this will be much very less water is used. Okay, and if you are interested in animal integration, you can go for extensive. Don't incorporate with aquaponics.
Yeah.
Yeah.
There is a question from Sudhirta Bose.
Yes, sir.
Is there any known method for treating fish diseases by using medicinal plant extracts?
Yes, sir. So we have also personal experience. Normally, episodic ulcerative syndrome, and I think I did my PhD from St. Xavier's College, Palamkotai, with the well-known professor Dr. Anifa, and we used to get a lot of disease infection in snakehead fish, Viralmean in Tamil we used to call. So for controlling episodic ulcerative syndrome, we use neem and turmeric. We mix 1:1 ratio with little salt, and we apply for controlling the episodic ulcerative syndrome. And we have got a successful treatment for fishes. And neem and turmeric can be mixed in 1:1 ratio and controlled. Even normal salt water also can be controlled for controlling any freshwater bacterial diseases and fungal infection. Normal salt water.
Yeah.
Yes, sir. And people also have been explored ginger extract, garlic extract, along with neem also been explored for controlling disease and infection. Yes.
Thank you. There is another question from Sheila. Can we see with our eyes the fungal diseases of edible fish?
Yes, sir. Very, very prominent. The fungal growth will be very. You can see like kind of colorful with the naked eye. There will be filamentous growth will be there. I show one slide, right? It's a fungal growth. I think. Can you all see the slide? I think is previously I show. This is a fungal growth. Can you see here? The whitish growth is a fungal saprologinium. And can you see this is a fungal growth growing on the egg? The dark white actually is a fertilized egg, embryo. And overall, the slimy, spongy is a fungus, fungal growth. You can see the naked eye.
Okay.
Yeah.
One more question from Praveen Prasad. What is your view on seed treatment method?
Say again, sir. Say again. Repeat the question, sir. I couldn't hear you.
What is your view on seed treatment method? Please suggest in nursery tank herbal feed additives.
Seed treatment, sir. Seed treatment. Seed means fingerlings.
Is there any nursery tank herbal feed additives? He is asking herbal feed additives.
Herbal feed additives in hatchery.
Nursery tank method.
Okay. I need to look at literature. I'm not nursery. What herbal medicines have been used in hatchery conditions? I didn't come across any research articles.
Okay.
Okay.
One more question from Divya Bharati, Nadu.
Yes, sir.
Is there anything imperfect in the term FCR, food conversion ratio, used in fish culture? Can we improve it? The question is there anything imperfect in the term FCR, food conversion ratio, used in fish culture? Can we improve it?
For improving the food conversion ratio, a culture method and stocking, very, very important. And the quality of the feed and quality of the feed ingredients have been used in aquaculture. Okay. So we can improvise the food conversion ratio. If you provide appropriate, the dietary energy for the fish growth, you can target even up to 1 FCR. In tilapia has been reported 1 FCR. 1:1 ratio, food conversion ratio.
Yeah, so this is a question from our student, Mr. Karthi.
Yes,
so
sir.
people are using many antibiotics in aquaculture for getting a good flesh in fish. How it affects the human while they consuming this antibiotic feeded fish?
Definitely, sir. There will be effect will be there. Antibiotic residue will be present in the fish tissue. When you consume, that antibiotic will be there in your body also. Sometimes antibiotic will not be metabolized. Okay, the activity definitely will be there. But no such study. The side effects in human, not much explored. But people they have studied, is there any antibiotic residue? People consuming fish, and is there any kind of antibiotic is there in the human being done? But side effects not been much explored in human.
Yeah. So the last question from Lata Sharma.
Yes, sir.
Can we use the aquatic plants as immunostimulants? If we use, how to use this aquatic plants as immunostimulants?
A lot of aquatic plants have been used. A lot of marine aquatic weeds, marine aquatic algae have been used in aquaculture, especially spirulina and red algae, brown algae have been used in aquaculture, fish feed formulation as a protein source, as well as immunostimulants. Number of research papers are available from marine algae and marine seaweeds, microalgae and macroalgae. And aquatic plants also been utilized. Yeah.
Thank you, sir. Thank you for your exemplary answers for all the questions asked by our participants.
Yeah, thank you, sir. Thank you. It's a nice
so it's a time for acknowledging the people who helped us and our resource person. So for that, I call upon one of the organizers of this international webinar, our department professor, Dr. David Raja, to propose vote of thanks. Welcome, sir.
Thank you, Francis A.B., sir. A very pleasant good evening to all. I am very happy to deliver the vote of thanks in this grand webinar on role of herbal immunostimulant in aquaculture. First of all, I would like to thank God Almighty for this wonderful day. Next, I would like to extend my sincere thanks to Reverend Father Rector, Reverend Father Secretary, and Reverend Father Principal for their constant support and blessing. Thank you, Father. I wish to express my sincere thanks to Dr. K. Marimuthu, Professor, Department of Biotechnology, AIMST University, Malaysia. Sir, your presentation is more informative and very useful to the aquaculture field. I hope all the participants are stimulated with your presentation towards aquaculture research. Thank you so much for accepting our invitation to be here as a resource person. Thank you, sir.
Thank you, sir.
I also thank Dr. Sagai Satish, Dean of Biological Sciences, and Dr. S.R. Senthil Kumar, Head of the Department of Botany, for their constant support and guidance. I especially thank Dr. Kaniki Raj for his technical support. Thank you, sir. I convey my sincere thanks to Dr. T. Francis Xavier, the very active organizing secretary of this webinar, for his hard work and wonderful planning. I'm very glad to thank Dr. Jani Kumar Tagur for his support. I also express my sincere thanks to all the staff members of Life Science Department for their fullest participation and engagement. Thank you, sirs. I wish to express my profuse thanks to all the student volunteers for their excellent support throughout the program. Thank you, friends. Finally, my special and hearty thanks to all the participants from various regions of India and abroad for your active participation and response. Thank you, friends. There are no incurable diseases, only the lack of will. There are no worthless herbs, only the lack of knowledge. Thank you, one and all. Stay home, stay safe. Thank you.
Thank you, sir. Thank you for your nice vote of thanks. So, at this moment, I would like to add thanks to Dr. David Raja. He is always supporting me to organize this kind of webinars. Thank you, sir.
Thank you, sir. Thank you. Welcome, sir.
Yeah. Once again, I thank our resource person on my own behalf and the Department of Botany behalf and St. Joseph's College Management behalf. I thank our resource person for his excellent and exemplary talk on the given topic. Thank you, sir.
Thank you, sir.
Thank you very much. So, dear participants, so this is for your note. So tomorrow, the third day of this 4-day international webinar series will be started at 5 p.m. of tomorrow. So instead of 11:30, we will start the third day session on tomorrow by 5 p.m. So please be with us. So have a great day. Thank you.
Thank you, sir. Can I leave? Yeah.
Yes, sir. Thank you so much.
Thank you, sir.
Thank you.
Thank you so much, sir. Thank you.
Thank you.
Thank you, David.
Okay, sir. Thank you.